Today I want to talk about alternating current and direct current, shortly called AC and DC. Exactly what are they? Let's talk about them. Current is divided into two types according to its direction of flow in the electric circuit. One is direct current DC and another is alternating current AC. What is DC? The current which does not change the magnitude and direction in the circuit is called direct current. Look at these two words, magnitude and direction does not change in the circuit, then that current is called direct current. We can understand with the help of this circuit. This is a cell. Cell is connected to a bulb and there is a switch also. And if we switch on the circuit, then current flows from positive terminal to negative terminal. It never changes its direction. It never comes back from negative to positive. And it always flows from positive to negative. And if the value of current is 1 ampere, it remains same 1 ampere. It never increases, never decreases. It remains constant 1 ampere. This is the meaning. The direction of flow of current is always from positive to negative and its value, magnitude remains same. This is the meaning of this definition. But what is alternating current? The current which keeps on changing its magnitude and direction in the circuit is called alternating current. This is just opposite of the direct current. Magnitude keeps on changing and direction of flow is also changing. What it means exactly? It can be understood with the help of a diagram. This is the source of alternating current and it is symbolized like this, and it is connected to bulb and a switch is also placed in the circuit. When we switch on the circuit, then what happens? One of the terminal of this AC source becomes positively charged and another terminal becomes negatively charged. And we know that current flows from positive to the negative. That's why current starts to move from this right hand side to left hand side. But while moving towards left hand side, I mean to say positive to negative, the rate of flow of charge, which we say current, keeps on increasing in this bulb. First, per unit time, less amount of charge enters into the bulb and keeps on increasing. When it starts to leave the bulb, then the rate of flow of charge keeps on decreasing and decreasing. And when it reaches to negative terminal, then bulb doesn't get current at all. Within fraction of second, the negative terminal becomes positive and positive terminal becomes negative. Now, the polarity of current keeps on changing and it keeps on changing in such a way that many times a second it changes. And when the another terminal becomes positively charged, then current moves from this terminal to the previous terminal. At this time, the rate of flow of charge which enters into the bulb keeps on increasing and increasing, and when it leaves the bulb, then rate of flow of charge in the bulb keeps on decreasing and decreasing, and it reaches to the previous terminal. This way, the magnitude also keeps on changing and direction of flow of current also keeps on changing in case of alternating current. Now let's talk about the graphical representation of the same DC and AC. DC. In x-axis we have to take time and in y-axis we have to take current. As we know, the direction of current never changes and its value remains same. So, the graphical representation of DC will be a straight line parallel to time axis. And if the flow of current is 1 ampere, it remains 1 ampere. It won't increase, it won't decrease. It remains constant. And this is the graphical representation of DC. But for AC, the same way, in x-axis I have taken time and in y-axis current. Let's say in a circuit, the flow of alternating current is 1 ampere, then we can represent like this. 0 is mid value and maximum is 1 ampere in both the sides because current keeps on changing its direction. I want to explain with the help of previous circuit. Look at this circuit. When this terminal becomes positively charged, then current moves from positively charged terminal to negatively charged terminal. At this time, what happens? When current enters into this bulb, the value of current keeps on increasing and increasing. 0.1 ampere, 0.2 ampere, 0.3 ampere, and I told you that if 1 ampere current is flowing through this bulb, then at last maximum current 1 ampere flows through this bulb. And when it leaves the bulb, then it keeps on decreasing and decreasing and decreasing. It means 0.9 ampere, 0.8 ampere, 0.7 ampere. And when it leaves the bulb completely and reaches to negative terminal, then bulb wouldn't get any current at all and the value of current becomes 0. And it can be represented like this. The value of current keeps on increasing from 0 and goes to maximum value 1 ampere, and again it decreases from 1 ampere and comes down to 0. But within fraction of second, this negative terminal becomes positive and positive terminal becomes negative. Now current flows from this positive terminal to negative, just opposite of the previous. And when current enters from this bulb, then what happens? The value of current keeps on increasing which enters into the bulb. 0.1, 0.2, 0.3, 0.4 ampere. It keeps on increasing and increasing, and maximum 1 ampere current passes from this bulb. And when it leaves the bulb, its value goes on decreasing 0.9, 0.8, 0.7. This way at last the bulb doesn't get any current at all and the value becomes 0 and current reaches to this terminal. This way, within fraction of second, the polarity of current keeps on changing. It happens many times a second. Now the same can be represented this way: from 0, the current goes on increasing and increasing and increasing, becomes maximum, and again comes back to 0 when it comes from the left hand side to right hand side. And not only many times a second, current keeps on increasing and decreasing. That's why it can be represented this way graphically. This is graphical representation of alternating current.